Hi students, this is Ms. Johnson with 7-1 Multiplying Monomials. Our sabbat for today is we're going to multiply and simplify monomial expressions. Well, let's get some vocab words, because first of all, what is a monomial? Well, mono means one, so we're going to have stuff with just one term. So it's a number with a variable, it's a number that can have a variable, and it can have an exponent, but there's no adding, subtracting, or dividing. For example, 10 is a monomial. 4h squared is a monomial. But f plus 24 is not a monomial. We're going to work a bunch with exponents here today. So we've got a couple rules. And the first one is a product of the powers rule. And product of a powers rule is when you have a problem like b to the third times b to the fifth. This rule says that you can just go ahead and add these exponents together to get b to the eighth, when you've got the same base. The reason that is because b to the third is like b times b times b, and b to the fifth is like having 5 b's. When you multiply them all together, you can just count them up and it's 8 b's, so b to the 8th power. Next one, power of a power rule. Power of a power rule says that when you've got a base to an exponent to another exponent, this rule says that you can just go ahead and multiply the exponents together. 3 times 5 to get 15. And the reason is because you can have b to the third, b to the third, b to the third, b to the third, and b to the third, 5 of them, and we just multiply those all together, add them all up, 3, 3, 3, 3, and 3, which gives us, obviously, 15. So the shortcut is just to multiply them. And the last one is a little more complex. It's power of a product rule. And power of a product is when you've got a problem like negative 2x y to the third inside parentheses, and then to the power of 5 outside the parentheses. And what you can do is this exponent kind of gets distributed. It's like getting distributed to each thing inside the parentheses. So you've got negative 2 to the 5th power. So you've got negative 2 times negative 2 times negative 2 times negative 2 times negative 2 gives us negative 32. Then we do x to the 5th power, which is x to the 5th power, and then y to the third to the 5th, the 5 gets distributed, and the power of a power rule from up above gives us y to the 15th. Okay? Alright, let's get into an example problem. Example number 1. We need to simplify each expression. So the first one, we got 6n to the third times 2n to the 7th. What we're going to do is we're going to multiply the whole numbers, and then we're going to multiply the like variables. So first we're going to do 6 times 2, which is 12, and n to the third times n to the 7th is we're going to be able to add those exponents together, and 3 plus 7 is 10. So our answer simplified is 12 n to the 10th power. Next one, we've got 3p t to the third power times p to the third power t to the 4th power. And we're going to follow the same sort of general rules. Is we've going to multiply the whole number. So we've got a whole number 3. We don't have a whole number over here, so it's like a 1, so 3 times 1 is 3. We're going to multiply the p times p to the third, and just a reminder, there's that imaginary 1 for the exponent. So when we have p times p to the third, it's really like 1 plus 3 is going to be p to the 4th power. And then t to the third times t to the 4th, add those together, t to the 7th. So altogether we're going to have 3 p to the 4th, t to the 7th, all nice and simplified. Alright, next type, power to a power rule. G to the 6th to the 7th. Rule says we can multiply these exponents together, which would give us g to the 42nd power. Alright, problem B. 2 to the third, to the 2nd, to the 4th. We've got parentheses and we've got brackets here. And this one's a little bit more complex, but that's alright. Just start inside the parentheses and work your way out. So, we got 2 to the third to the 2nd. Power to the power rule says we can multiply these together. So we can multiply the 2 times the 3 to get 2 to the 6th power, leave our brackets, and to the 4th power on the outside. Now we can distribute that. So 6 times 4 is 24, so we get 2 to the 24th power. And these are all numbers. The other examples I've given to you had variables, so we can actually simplify this number, figure out what it is. 2 to the 24th power is 16,777,000. the last example, example number 3, is we're going to put all of these rules together. And we're going to simplify. 3xy to the 4th power, everything to the 2nd power, times negative 2y to the 2nd power to the 3rd power. And yes, this looks a little crazy, looks a little complex, but just go step by step. Okay, so let's take the first part. There, got everything to a power, so we're going to distribute that power through. So we're going to take this problem on, this part on the left, separately from the problem on the right. So let's distribute the 2 to the 3, to the x, and to the y to the 4th. And we'll do the same thing over here, starting inside the parentheses, distribute the squared through. Okay, here's what we get. 3 to the 2nd power, x to the 2nd power, y to the 4th to the 2nd power. Part on the right, we've got negative 2 to the 2nd power. Notice you got to keep the negative in there. Those little negatives might trip you up, so be careful. And then y to the 2nd power. Keep the brackets, keep the to the 3rd power on the outside. Alright, let's simplify this. 3 to the 2nd power, well that's 9. X squared. Y to the 4th to the 2nd, we can multiply those together to get y to the 8th. Negative 2 to the 2nd power, negative 2 times negative 2 is 4. And then we got y squared. Alright, now we got to keep going. Keep simplifying it. We've got the power to a power rule again with the brackets, so we're going to distribute the power of 3 to each thing inside. I'm going to leave this left part alone. So we're distributing the 3 to the 3rd power. So we got 4 to the 3rd power and y to the 2nd to the 3rd power. Simplifying that, we get 64 y to the 6th power because we can multiply the exponents. Alright, now we don't have any more power to a power rule. Now we can go back and we can just multiply whole number times a whole number. We don't have any x's to multiply. And then y's times y's. So 9 times 64 is 576. Keep the x squareds, and simplifying the y's, y to the 8th times y to the 6th is y to the 14th power. Okay, so take care of the power to a power rule first, do some simplifying, and then at the very end, multiply your like terms. Alright, summary. You can do your summary right now on your notes, you can do your summary sheet tomorrow morning, or you can create a foldable study guide. Take your pick which of these 3 you would like to do. Alright, that was 7-1, Multiplying and Simplifying Monomials.